Hello everyone, I am going to explain question 15 of exercise 2.1 of class 12. So as you can see, the question is, if tan inverse x, tan inverse y, tan inverse z are in arithmetic progression, then prove that y square bracket x plus z plus 2y bracket 1 minus xz minus x minus z equal to 0. So here the given information is these three terms are in AP. Then by using this information we have to bring this result. So when we'll solve, we'll also start by the given information, that is tan inverse x, tan inverse y, tan inverse z are in AP. So you know the formula, that is basic formula of 10th class from AP, that is if three terms A, B, C are in AP, then the middle term is the average of these two terms, means B is the mean of extreme terms, it is B is equal to A plus C upon 2. So here we will use the formula. So the three terms are tan inverse x, tan inverse y and tan inverse z. So here the middle term is tan inverse y. So conclusion by this formula is tan inverse y is the mean of tan inverse x and tan inverse z. So to find out the mean of tan inverse x and tan inverse z is sum of data upon number of data. So sum, we added them, number is how many data we have, that is 2. So tan inverse y is equal to tan inverse x plus tan inverse z upon 2. Now this 2 is in division, so we will shift here, so it will come in multiplication. Now after this 2 tan inverse y. To solve this, we use the formula of 2 tan inverse theta equal to tan inverse bracket 2 theta upon 1 minus theta square. So here students, theta is y. So when we use the formula, tan inverse bracket 2 theta upon 1 minus theta square, that is y square. Now here we will use tan inverse x plus tan inverse y formula, that is tan inverse x plus y upon 1 minus xy. So instead of xy we have here xz, so we use the formula. Now why we had used both the formulas? Because both the side tan inverse should come, so that we can remove the tan inverse, because whatever result we have to bring in that, there is no trigonometric ratio. That's why we had brought in both the sides tan inverse. Why only tan inverse? Because easily we can bring by the given things, that's why. So tan inverse and tan inverse will remove each other. We are remained with only these variables. Now simply just cross multiply them. After cross multiplication, you just see I kept this bracket as it is. Why? Because in the question this bracket is as it is, they had not opened it, and this bracket I opened and I adjusted according to the question's requirement. This further I not opened, I shifted this complete bracket this side, because in question it is as it is, and this bracket I opened and shifted, so sign is changed. So by observing what is required thing, after cross multiplication, move according to that, you will get your answer. So this question is completed. Now just see the question number 16. Question 16 is, if alpha, beta, gamma be the root of equation x cube plus px square plus qx plus p equal to 0, then prove that except a special condition tan inverse alpha plus tan inverse beta plus tan inverse gamma is equal to n pi. Also find the special condition when it does not so. So here what is given to us, that alpha, beta, gamma are the roots of this polynomial. So this is given to us, that these three terms are the roots of this polynomial, and by using this information we have to bring this result. So we'll start by using this. For that, first I want to mention you that what is the relationship between the roots and the coefficient of a polynomial. So I wrote here general polynomial, then we'll move to the questions polynomial. First I assume if alpha, beta, gamma are the root of a general standard polynomial, that is ax cube plus bx square plus cs plus d equal to 0. So it's a cubic polynomial, because in question also they took the cubic polynomial. So now I mentioned here the three relationship between the roots and the coefficients. So coefficients are A, B, C. These are the coefficients of the variable and this is constant, and alpha, beta, gamma are the roots. So the first relationship is alpha plus beta plus gamma is equal to minus B upon A. Now these results also very easy to write it. This A you just keep for only for division. Just see here, in first result also A is in divide, in second result also A is in divide, and in third result also A is in divide. So A coefficient means the highest powers coefficient is for the division. Now then we'll start by the second powers coefficient, that is x squared coefficient B. Then always the relationship starts from the minus sign. So minus B, then upon A. The next, this sign used to come alternately. First minus, then plus, then minus. It used to go like this. So A is for the division. Then we started by B. So minus B upon A. Then C upon A. Then minus D upon A. So these, they used to come always in the sequences. Now here you have to learn how these roots used to come. First, simply the sum of the roots. If somebody tells you find out sum of the roots, then what you will do? Alpha plus beta plus gamma, that is means single root in the summation. Then pair them in twos, means alpha beta, then beta gamma, then gamma alpha, then all three together. So we started by single, then twice, two together, then all three together. So very easy to learn these three results. Alpha plus beta plus gamma is equal to minus B upon A. Why? Because second coefficient is B, and we have to start first by minus symbol, then plus symbol, then minus symbol. It used to go like this. So these are the three relationships between the roots and the coefficients. Now these three relationships we use in our question. Now just see our question. Our question's root is again same, alpha beta gamma, but the polynomial is different. Just see the coefficient. Instead of A we have here 1, and instead of B we have here P, and instead of C we have here Q, and instead of D we have here P. So in this result here we will replace A, B, C by 1, P, Q and P. So we'll instead of this equation 1, 2, 3, by all the replacement we'll get the three relationship between the alpha, beta, gamma and the coefficient of the polynomial which is given in the question. So alpha, beta, gamma is equal to minus P upon 1, and in the same way next will come Q upon 1, then will come P upon 1. First minus sign, then plus sign, and then again minus sign. And here you know, first single roots, then two roots together, then three roots together. So we achieved these three equations with the help of equation 1, equation 2 and equation 3. Now these are the three information which we achieved from the given thing. Now we'll start to prove the required thing in the question. Now in question we have to prove this result. So we'll start by solving the left hand side. Left hand side of the question is tan inverse x plus tan inverse alpha plus tan inverse beta plus tan inverse gamma. So I wrote here left hand side, and you know that in tan inverse if we have to add 3 tan inverse, then the formula is this. So in formula we had used, instead of xyz we have alpha, beta, gamma. So I use the formula of tan inverse x plus tan inverse y plus tan inverse z. We got this result. Now here alpha plus beta plus gamma, just see in this equation alpha plus beta plus gamma is what? Minus p. So here instead of alpha, beta, gamma I wrote here minus p, and here we have alpha, beta, gamma. So what we have alpha, beta, gamma here minus p. So this minus is already there in the formula and its value is again minus p. Now here you just see, if we can take minus common, then in the bracket we will get alpha, beta plus beta, gamma and plus gamma, alpha. So alpha, beta plus beta, gamma plus gamma, alpha value is q. So we will get here, instead of these three terms we will get here q. Now just see the numerator. When we will open this, minus into minus become plus. Now they are opposite, so they will subtract and answer will come 0. Now 0 divided by any number is 0. Now, but you know that if 0 divided by 0 becomes infinity, so it's not going to be 0 until q becomes 1. If q becomes 1, then 1 minus 1 will be 0 and 0 upon 0 becomes infinity. So except this condition, it's always is going to be 0. So tan inverse 0 value is n pi, that is our right hand side. So the special condition for which the result is not going to be this is q is equal to 1, because if q is equal to 1, then here it's going to be not 0, it's going to be infinity. So the special condition when it is not so is q is equal to 1. Thank you.